Hello, good afternoon, and welcome back to the tutorial on demethoxylation of aryl methyl ethers. This is the part B which we shall be discussing today. In part A, we had discussed how we can use aluminum chloride, which is the most versatile reagent and has a very big amount of literature available on aluminum chloride. So we isolated it as a part A. And this tutorial we have kept only for discussing reagents other than aluminum chloride. So we are talking of demethocylation of aryl methyl ethers, and this is the reaction which we are talking of, for example anisole to phenol, and this is one of the most common reactions which the organic chemist comes across in almost 15% of the synthesis that he does. From a process chemist point of view, what he keeps in mind is that he has to commercialize the product, and so an important part is the cost. He has to keep the cost low, and he has also to carry out the product on a commercial scale, which is a scale bigger than the lab. So these things, if he keeps in mind and develops the process accordingly, he has a good chances of a very good process that he has developed for the commercialization. So this line I have added specially for BBr3 because I couldn't find a better reagent than BBr3 for the demethocylation of this aryl methyl ethers, and the rest of the reagents are not as good as BBr3, but this BBr3 is an expensive reagent and may not be commercially viable all the time unless it is being used at the later stage of the downstream part of the process where value has already been added to the product. So these are the reviews which I had come across. People who are interested may go through these reviews. These are the important ones which I came across, and this is another though not exactly a review, this was a patent which gave a detail of many reagents that are available in the literature, and an interested chemist can go through this patent and the cross references given therein. There are other reviews which I have not gone through much, but because since these are older reviews, but they are still important to go through if at all required. So we come to the first of the procedures. This is using diethylaminoethanol. This is a good reagent, and the important thing here is this has to be carried out in presence of base. The bases are given and the solvents are DMF and N-methyl pyrrolidone. They give good yields, but the solvents like DMSO and THF are reported here to give much lower yield. So that can be a heads up for the chemist to start an optimization and in the selection of solvents. Another paper is with HBr and AlCl3 AlCl3 is an ionic liquid. It is a quaternary ammonium salt, and good yields are reported with this type of catalysts. The only drawback with HBr is sometimes since HBr is a gas and the temperature which is being used here is 105 degree, over a period of time the HBr keeps escaping from the reaction, and it is quite possible that the reaction slows down or stalls during the end. So maybe more HBr will be required to be added to the reaction towards the end. Another one, demethoxylation is reported with HCl in water, but if you have a good facility for your pressure reactions, maybe you can try this type of reaction in your lab. And I wonder if it is available at a commercial scale, which is rarely available. uh, the conditions are 250 degrees centigrade and pressure is 50 bar. This is like, it is not a very easy approach, though looks like a cheap uh, procedure, but it is not going to be an easy thing to do at the plant. And another one is reported in sodium iodide plus BF3 ethylate. The ratios are given as 1:2:2. Ether is 1, sodium iodide is 2, BF3 ethylate is 2 mole equivalents, and it is this type of reaction is done in acetonitrile and can be optimized if required. This is also a good method reported, and this is widely used procedure in the chemical industry, where it is dodecanthiol. Dodecanthiol in presence of sodium hydroxide in N-methyl parledone. This gives a good yields and is worth trying if your compound is stable with respect to sodium hydroxide and it doesn't decompose in sodium hydroxide, and the yields reported are very good, like 90%. This is another one. Strangely, I came across this with methyl magnesium iodide, which is a Grignard reagent. If at all your compound is stable and not reactive to a Grignard reagent, methyl magnesium iodide, this is a reaction worth trying, and this is not that expensive also, and it is a neat condition. Methyl magnesium iodide neat at 160 degrees centigrade for 1 hour. So the reported yield is 60%. It is not like an optimized condition. We chemists can optimize the condition and have better yields than what has been reported here. Another example of use of methyl magnesium iodide I could come across is given in this reference, Journal of American Chemical Society, and this too can be tried. This is a simpler method with 48% HBr acetic acid, and the only problem, like I told you earlier, was the loss of HBr over time, and that can be compensated if at all it works for you. This is a good reaction with pyridine hydrochloride, and this reaction goes well in normal heating conditions. Typically temperatures are high, around 150 degrees centigrade, may require around 170 degree even to increase the rate of the reaction, but the yields are good and this reaction is worth trying. And this is an example where pyridine hydrochloride was used at 180 degrees centigrade to produce 4-hydroxyphenyl butyric acid. This is the reference if at all somebody wants to go through the reference and try the reaction under the conditions given in the paper. It is a similar reaction with pyridine hydrobromide in sulfolane, but if your reaction is already going in pyridine hydrochloride, and this is an alternative to that. If it doesn't go in pyridine hydrochloride, maybe this can be tried. Even pyridine hydrochloride can be tried in sulfolane. So sulfolane is having a very high boiling point, so the temperature can be taken up to 150-160 degrees centigrade. That is the advantage of using sulfolane here. That was all regarding the demethoxylation of um, aryl methyl ethers. Hope it adds value to your knowledge, and look forward to see your comments, and we will take up other such lectures after I get the feedback from all of you regarding how the things are going. Thank you.